Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, 01 knapsack problem. So what the problem is saying is, we'll be given a knapsack. Okay, a knapsack is, you can consider a bag. Okay, and will be given a weight array, a value array, and a weight of the knapsack. Okay, this particular bag. Okay, so what is this weight array? Okay, so the weight array is the array which contains the weight of the items to be put into this knapsack. Okay, and the value array is the value of the items For example, for this particular item, the value is 3. For this particular item, the value is 2. For this particular item, the value is 1. Okay. So what we want to do is, we want to ingest, or we want to insert, or we want to add the items in this knapsack in such a way, okay, so that the weight of the items which we put into the knapsack, it does not exceed this particular weight of the knapsack, and we get the maximum value of the items which are added in the knapsack. Okay, so this is what the problem is. We want to add the items in such a way that it has a maximum value in the knapsack. Okay, so this is a problem. Okay, so how can we solve this problem? Okay, how can we solve this problem? For example, so what we're going to do is, let's say here is a weight array, right? Here is a weight array. So at each item, right? At each item, we will have two choices, whether to take this item or not. Okay, whether to take this item or not. Okay, so what we are going to do, for example, also we are going to check whether this particular weight, if it is lesser than this particular weight, if it is lesser than, for example, if it is lesser than this particular weight, then we are going to take the corresponding value. For example, what is the value here? Value equal to now. Now, since we have taken this, right? We have taken this, the value will be 3. And what will be the remaining value? What will be the remaining weight? So it is going to be 4 minus this 1, right? So the remaining weight, the remaining weight of the knapsack, it is 3 now. It is 3 now. Now again, we have choice here, right? So we have two choices, 3 and 5. So definitely the remaining weight, right? 3, it is lesser than 5. So we cannot add this particular item. We cannot add this particular item into the knapsack. Okay. So only thing is, we'll have to skip this. We'll have to skip this weight. Similarly, we'll come to this weight. Okay, we'll come to this weight. Here again, 3 is lesser. The remaining capacity of the knapsack, it is 3 only. And the weight of the item is 4. So we cannot ingest this particular knapsack. So what will be the value? What will be the value? So we have exhausted this weight array. So final value will be 3. So if you see, the final value will be 3. Okay. So what we want to do is, even if, for example, if such was the case, like 4, and let's say 2 and 1. So we'll start with the last element. Okay, we'll have two choices, whether to take or not take, right? So if we take the remaining the remaining weight of the knapsack, it is going to be 3. That is 4 minus 1, it is going to be 3. If we don't take, then the remaining weight will be as is 4, right? So in this case, so we'll have two branches or two calls. Okay, two calls of recursion basically. Okay, to take or not take. Each item will have two choices, to take or not take. So why we are doing this? So to have the maximum value. So to make sure to have the maximum value of the items which will be inserted into the knapsack. Okay. Okay. So this is an intuition when solving the problem. I hope you've got the intuition. I think let's go to the code. Okay. You'll understand better. Before going to the code, I'll also request you to subscribe to my channel, like the video, because I've observed that 90% of the viewers, right? They do watch the video, but they don't subscribe to my channel. Okay. It will be really helpful to me if you subscribe to my channel. Thank you so much. Let's quickly go to the code. Okay. So let's say first, okay. So what, as I said, we are going to have two choices. Okay. So first, let's write knapsack util. Okay, knapsack util. Let's write knapsack util. So we'll write a function knapsack util. Okay, and we'll have the int n equal to weight dot length. Okay, so we are taking the length of the weight array, or the length of the items, right? The size of the items. Okay. So here, what are we going to do? We are going to pass weight, the weight of the knapsack. Capital W is the weight of the knapsack. Weight array, val array, and this n minus 1. Okay, which will treat as the index, the last index of the element, right? So here we have, okay, I don't know why it was earlier static only. Let's have static. Okay, so static int knapsack util. Let's quickly write the code. Int w. Then we have this weight array. Then we have this value array. We have this idx. Okay. Okay. So now what we're going to do? First of all, if 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 weight minus wt of idx, right? If it is greater than equal to 0, then only this particular item, this particular item at weight, right? The item at idx, at index idx, if it is less than or equal to weight, then only it is possible to add into the knapsack, right? So that is why. So let's say the value will be a. So okay. So what we are doing is we are considering this particular, we are going to consider this particular item. So we are going to consider the value as well. So here we are we are going to take the corresponding value. Okay. And then we are going to call the recursion again for the next item. Okay, for the next item. So weight. So weight, it is going to be reduced now since we are considering the weight, right? Since we are considering the current item. Okay. Okay. Second is weight array. It is going to be as is value array and then idx minus one. We have taken this. We have taken this particular. We have considered this particular item. Okay. Now the second choice. Even if the second choice is what? We won't take the particular item. We won't take this particular. We won't consider this particular item. Even though, for example, if the weight is still lesser than the knapsack weight or it exceeds, right? If it exceeds the weight of the current item, if it exceeds, then we don't have choice. We have only one choice to not take it. Okay. The other scenario is even if the weight of the particular item, if it is lesser than the knapsack weight, then still we are taking the second choice, right? Of not taking that, of not considering that item. So what we're going to do? So simply let's call this function util, and we are not going to deduct as this weight, right? As we are not considering the weight. Okay. And we'll simply move on to the next element. Okay. To the next element. Okay. So this we have two choices. Now what we're going to do? We are going to return the max of the two choices, A and B. Okay, A and B. So it may be the case, for example, if this was the case, right? 4, 2, 1, right? And what is the weight of the knapsack? 4. So even if I don't consider this, right? Even if the weight is lesser than the current weight, right? Then the current weight. For example, the value here is 1, 4, and 1, for example. So if I don't take this item, if you see, right? If I don't take this particular item, right? So what is the value which I won't consider? This is a value which I won't consider, right? If I don't consider this item, even though its weight is lesser than 4, right? Even though its weight is less than 4. So, but if I don't consider, if I consider this one, right? If I consider this one, then what is the value? The value is greater. Okay, the value is greater. So even if a particular item, even if its weight is lesser than the knapsack, and if I don't consider, there are chances that I can get higher value. So in this case, if you see, right, we'll get 4. If I had considered this, I would have got 3 only. Here I'm getting 4, higher value. Okay, so that is the reason. So we are going to take max of A, B, right? So this is a problem. Okay, this is a solution. Okay, this is a solution. Now let's also have the base condition. If idx, if it is lesser than 0, if it is gone lesser than 0, then simply return 0. Okay. So this is the solution. Now here, since we are calling recursion 2 times, right? So there can be overlapping sub problems. Okay. So what we're going to do in this case, we are going to use dynamic programming. So we'll use memoization basically. Okay. So what we'll do, we'll have a DP array of what? Of size n plus 1, right? And and W plus 1. Okay, W plus 1. Okay. So here we are going to initialize this DP array with -1. Okay. So for int row, okay, what is, yeah, DP. Then simply what we're going to do, arrays dot fill row with what? With -1. With -1. Okay. So what we're going to do here, we are going to pass DP array. Okay. Here we have a DP array and we are going to check here. So when we return, right? So for this particular DP of IDX, right? What is N? N is the number of items, and the weight of the particular knapsack, right? The current weight of the knapsack. Okay. So we are assigning before returning, we are assigning to DP of IDX weight. Whatever is the current index, okay, what is the item and what is the remaining weight, okay. And now here also we are going to check if for a particular item and a particular weight, if it was already solved, it was already computed, then simply we are going to return here only, we'll save the recursion calls again, okay. So this will be optimized basically. So here it is. So this is a memoization. Let's quickly compile this. Okay, what it is saying. Yeah, we have not passed. Let me also take this above. So DP. Here also will take DP. Oh, what are we doing here? And we should have passed like this. My bad. Again. Yeah. Simply return. Some compile time errors. I hope there shouldn't be any compile time error. Let's submit now. I hope the test case should pass. Yes, the test cases are passed. I hope you have got the solution. Okay, please subscribe to my channel, like the video. Let's quickly see the C++ code as well. Okay, so here is the C++ code. So here's an knapsack function. We have taken n. Okay, the number of item size. Here we have taken the DP array. Okay, we are considering the DP array of number of items and the weight of the knapsack. Okay, so here we have the DP array, and here we are calling the util function. Okay, so what we are doing here is, first let's check this. If the weight of the item, if it is lesser than the knapsack, okay, if it is lesser than the weight of the knapsack, then consider, one choice is to consider that value or that item, okay, and reduce the weight of the particular item from the knapsack weight, okay. Take the next pick up, go for the next item, okay. So this is one choice to consider that particular item, right? And the second choice is to not consider. If you see here, right? So here we are not considering. We are not considering that particular item. Okay. So we are taking the max of that. And what we're doing, the max, whatever is the max, we are assigned to this memoization array as well. So here, if you see the check, if it is the memoization, if for a particular item, right? And the weight, if it was already computed, then simply return. Okay, save some calls. Okay, and here is if the IDX goes below 0, then simply return 0. So this is a solution. I hope you have got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.